Okay guys, welcome back. In this video, as I mentioned previously, that we will work on the trusses. We'll start with the 2D trusses. The units, make sure that you select the unit as per your convenience. I have selected keep fit. I will click on this 2D trusses, and it will right away take me to this window where it asks for the type of 2D truss that I want to model. Please note that there are three types of trusses available here in the 2D menu. The sloped truss, which you can see here. The second one is vertical truss. You can see the vertical members and the cross arrangement, and the Pratt truss, right? You can see this one. So you can work in either of them. For example, for the case for this slope truss, just for simplicity, I have selected this. The number of divisions, let's suppose 3. The division length is 12 feet. You can make it more or less, for example 10. The height, I make it 10 for simplicity. Okay. You can use the custom grid spacing and location origin. For example, if you want to make these spacing not even, so you can go to this edit grid, and just like in our previous video, you can edit in it. Okay. uh, Here, the section properties, you can click on this plus, and you can just make different sections for the chords, for the inclined members and for the horizontal members. You can import the property, you can add new property. For example, in the steel type, you can select I wide flange, for example, and you can define its parameters, okay, that suits you. You can define different sections or the same section, it is up to you. Just click on this. Okay. Now it has been formed, right? This is the model. Now just to compare with the structural analysis concepts, this is just statically determinate truss, right? It is not indeterminate, and in SAP, since it accounts for the self weight, so here I will make the self weight 0, so that it matches the results of your structural analysis concepts when you learn to analyze the truss in structural analysis 1, right? So this is your simple truss. Now the elements have been modeled, and you can check the details. For example, the section property frame section 1 has been assigned, and there are no loads. So let's apply the load. Select any joint. For example, I have selected this joint, and go to the assign menu, joint loads, forces, and you can apply the force in any direction, in horizontal or in vertical. For example, I want to apply a 5 kip force in the horizontal direction here, right? So it is 5 kip force applied here. Here I want to apply a vertical force, so I have selected it, and go to assign load and forces. Make this one as 0, and make the z in minus z, because the global z is an upward direction. So I want to apply a downward 10 kip force, and here I just want to leave it just like that. So this is now we have done with it. See, it is so simple. And what we have to do next is uh, go to this analyze option, or you can just click this play button, run analysis, and a window will open. uh, for now we are just working with this dead load, and select this model and click this do not run case. Okay, and make sure that it is do not run. In the later stages you will learn how to run this model analysis as well. So for the case of that, just run now, and it will ask you to save the model, and give it some name, and save it in your computer at a location that you want to save. For example, I give it name of 2D Truss, right? And see, this is the result. For example, I want to check the result of joints, for example, the reactions. So these are the reactions. Since this was the hinge support and this was the roller support, so all the horizontal forces have been restrained at this point. Similarly, the vertical forces, as you can see, the force of 10 kip was applied here, and 3.33 is resisted by this support, and 6.67 has been resisted by this support, just because of the presence of the horizontal force at this point. You want to check the member axial forces. So go to axial force, and you can select the field diagram option or show values on diagram, right, and click OK. So you can see that there are negative axial forces in these elements. The red one is the negative forces and the yellow one are the positive forces, right? So if this is minus 3.65 or 66, then this is plus 3.54. Similarly, this one and this one cancelling each other. These are cancelling each other. Okay. So in order to verify it, you can just check it manually, and you can analyze this stress, and you can just calibrate your model, and you can proceed further. So I hope you have learned how to model a 2D truss. Similarly, you can go to the new menu, select the truss again, and now this time select the vertical type truss, right? Make these same, the 10 10, also make it the in the similar way, just like we did it previously. Okay, and click OK. So here now you can see that the whole thing has been changed. A new truss type is there. You can put the loads, for example, here you can assign the joint load. Why I am using the joint load? Because in truss you can only apply the joint load, right? Here I want to apply, let's suppose, 8 kip of vertical load, and here I want to assign 12 kip of vertical load. Okay, now I want to run the analysis, and again I will not select the model, and I will click the run now. It will ask me to save the model first, so I will give it some name. What will be the name? It's up to you. For example, 2D truss vertical, right? So it's running the analysis. You want to check the reactions. These are the support reactions, you can see. Let me make it a bit clear for you. See, there was no horizontal force involved, so the reaction is 0. The vertical reactions 11.41 here and 12.75 because of the forces applied, and the member forces, the axial forces in each member. You can see the negative and the positive in each member. So that's how you analyze the 2D truss in SAP 2000. See you in the next video with the other options. Thank you very much. Bye bye.